these are the include files that need to be included in both the programs. The first one I'm calling is the shared memory producer.c, and the second one I'm calling is shared memory consumer.c, right? So these are the two files, and why I need to demonstrate is that you need to run this program a bit differently than we have done before. So we have these two windows, right? So, and actually let me, on the desktop you're going to save both the files. The first one we should be calling shm producer.c, and the second one we should be calling shm consumer.c, right? So then you will compile these files like this: shm producer.c, and this is the flag -lrt. So this is the flag you need to include, which is lrt. So if you do not include this flag -lrt, which is to do with the fact that the compiler needs to know if you're using a shared memory library. So if you are so this is the, you can say, requirement of the compiler. So if you do not include, so let me erase this -lrt and compile. So it says that the compiler does not recognize the shm open system call. But if I include the -lrt thing, now you see that the program has compiled. And similarly, if I compile the other file, which is the consumer.c, without the -lrt flag, I will get an error. But if I write the -lrt flag, my program is compiled. So here you can see that now shmc for consumer and shmp for producer, both of these executable files are created and are there, right? So now the second thing you need to know is that you need to have two windows opened up like these. This is the first one, let's say, and this is the second one. So both of these files, both of these terminal windows should be opened at the same time, and while they are open, you need to run the shm producer from this end, and while it is running, you see that it has stopped at this point and it is not doing anything. And during this, if you run the shm consumer file, you see that consumer has received hello world from the producer, and now I can press enter in the producer part and the producer program finishes. So if I run the consumer program without running the producer program, so the shared memory, the consumer program receives an error, or it's an exception that it is trying to acquire a pointer to a shared memory segment which does not exist. So what has happened is that this is the shared memory producer program, and this is the, let's suppose, shared memory consumer program. So when shm producer runs, it creates a shared memory segment which is inside the space of this producer process, and the consumer process is given a pointer which points to this shared memory segment, right? So if this shared memory segment does not exist and shared memory consumer program tries to access this pointer or try to get access to this pointer, it gets an error, right? So that is why we are getting an error if shared memory producer is not running. So if we keep it running and then we run the consumer program, we see that the consumer receives the message hello world from the producer. So you can, now we can go and have a look at the code. So this is the code for consumer, this is for producer. There are a lot of include files. These this one and this one, these three, these are required for shm open, whereas this one is required for uh, mmap, and these are required for these ones are required for string handling, and stdio or unistdio for standard input outputs. Now look at the program. The program defines a variable of name, size, and value 4096, and then it creates a string. Name is name and value is os, and two messages. This is message 0, this is message 1. Message 0 is hello, message 1 is world. And then the producer program creates a file descriptor just an integer variable, and a pointer, character pointer to a string type variable. Then it uses the shm open system call to create, and these are, by the way, these are called flags. O create and O reader are the flags. So what we are trying to tell this function shm open is that we want to not just have read write access to this shared memory segment. We also want to create it, because we are telling this system call that it this does not exist so far. So we want to create it from scratch. This is a new shared memory segment, and we are saying that the name, we are telling the operating system to name this shared memory segment as OS. Okay. So once this is done, and this is successful. By the way, we haven't written any error handling over here. There could be a error handling also, but we have skipped that part. This is a default number. You can say we use it every time we use shm open. It is related to different attributes of shared memory segment, which are by default kept the same using these flags. These are numeric values of different flags. Then f truncate uses this size, which is 4096, to limit the size or mention the size of this file, or indirectly the shm open. So this file descriptor is just a roll number of the shared memory segment, and you can use that roll number or that file descriptor to change the size of this shared memory segment using f truncate. And then you can use the mmap system call to retrieve or gain a pointer or get a pointer to, for this shared memory segment, and that shared memory segment is mentioned where in the system call? Over here. And by the way, in C language, it is a convention that whenever there are capital letters, these are constant values, like you see over here. It's a constant, so they are intended to stay the same during the life cycle of this of any program. So this flag is saying that this pointer is for reading and writing both, and this is again a requirement of the system called map shared, because we are not mapping to a new object, we are mapping to a previously created object, and fd is the file descriptor that it retrieved over here. So we cannot use the file descriptor. File descriptor is just a number to access a data structure which is inside operating system's address space, so which is registered. So we cannot really do anything with this roll number. So we need to get an actual pointer to this memory address, which we get using this command. And then what the next lines are doing is that we are actually printing to the system memory, and we are using this pointer, and we're using this format specifier, and we're using this message which is hello. So this command is essentially going to write inside the memory, print into memory this message hello. And similarly, we are going to increment to as many letters there are in the word hello. So this is str length message 0. So this function gets the size of this word, which is 5. So now pointer will be incremented by 5 values. So for example, it was pointer was previously pointing towards the memory address 100, which was the memory address of the shared memory segment. Now you have written to 5 values inside that shared memory segment. So let me actually try, and I hope this is very simple, but still I would like to, for some of you, mention what is going on over here. So for example, this was our program, right? So this is, for example, our program, and here the system has created a shared memory segment for us, and it starts at 100. So what we have done is we have written H here, E here, L here, L here, O here, right? So, but the pointer was currently pointing towards this. It was at the number 100. Now we need to bring this pointer to from 100 to, and we need to bring it to 105. So in order to bring it from 100 to 105, what do we need? We need to find the length of this word, which is hello. So the length we get using strlen function. This is the strlen function, and then we increment it by the same number of what we get from str length. Got it? So 100 plus 5 is, which is 5, which is the length of hello, is 105. Now pointer is pointed to this location. Here you start writing to the memory the second message, which is world. So now this world word will be starting from this WORL and D, right? So this is how this system is working. And on the receiver end, and now get character function is just used to stop the screen at this point and not go any further. And whereas the consumer process, whenever it starts, first of all, we are giving this name OS, providing this name OS to this program, because we know that we have set the name OS somewhere else in another program. So now this file descriptor is here, pointer is here. These are just new variables because this is a new context of consumer process. We are using the same SHM open, and we are using the name that we have mentioned in the producer process, and we are getting a file descriptor. Now, because the name is same in both the programs and it was previously created, we don't need to mention over here create. We just need to mention read write access, and we get the same file descriptor. So the file descriptor value should be the same. It will be exactly the same because we're using the same segment name. Then we mentioned ptr. This command mmap is used to retrieve using the file descriptor. This is the same command, and we are getting a pointer back. Same command as we used in the producer process. And now we are printing to the screen, to the display of this device, using this pointer, whatever is at this pointer, stored in this pointer location, and some format specifiers. And then we unlink from this, we unlink this program from the shared memory segment called OS. Any questions? So yeah, you can see there is no error handling. There is no kind of like that we are detecting anything, whether producer program is running or not, whether the OS shared memory segment called OS is already created or not. We are not doing any validation kind of thing. So it is just simply going on, and whenever this runs, it tries to get the pointer. If the shared memory segment exists, it gets the pointer and gets the string value from that location and unlinks itself and goes on. And as soon as we press enter at this point, it exists. Exit. It's called typecasting. So you can always, for example, if I write, I create a variable called, for example, character. The name is, let's suppose, E, and the value is S, right? So this is a character. But if I have like integer W, and I write something that W is equal to the integer version of E, right? So you see that character, the size character is also integer type, kind of like variable type, but character, the size of this variable type is only, I think, 1 byte, and the size of int variable type in most architectures is 4 bytes. So these are incompatible types if you directly talk about this. Like, for example, if you want to add 10 to E, value of E, which is the ASCII code for S, and you want to store in W, the compiler will give you at least a warning. So, but now what we are doing is we are telling inside the code to the compiler that first change the type of E temporarily to integer, and then assign whatever you get to the variable W. Got it? This is called type. You can call it type changing. Formally, it is called type casting. So we can live without this typecasting, which was redundant because we had already done it at this point over here. We were actually typecasting for whatever the return value of mmap was, to typecast it to character, because that would be, I think, the return value of mmap would be void star, because of the generality reasons. Let's check it. What is the return value of mmap? So you can see the return value of mmap is void star because it needs to remain general for any type. So the thing is, if I had to truly use the return pointer for mmap, I should have defined it like this, void star, and I should simply get this value mmap. But when I will be using it inside printf, I must then typecast. So this is an alternative version of the same code, and this will also work, right? Because this is probably the better way, because we are defining the pointer in the way that this mmap really requires a pointer to be in the format, which is void star. And then when you go to printing to the screen, it requires %s, which is string format. So then you should mention character star in front of pointer as a typecast. I think this version is better than before. Any other question? Now let me describe to you the lab task, and which is that you have to modify the behavior of the given code in such a way that when a character is typed in either of the windows followed by enter, the same character should appear in the other window, right? So right now what we are doing is that we are only writing from the producer and receiving in the consumer. So I want you to modify the code and try to think about a way in which you can modify in such a way that you can do it from both the directions, right? Any other question?